All right, so 4.2, we need to start off with a little bit of review. There's no calculus on this front page, so let's get through that review first, and then we'll talk some calculus. So sigma notation, Greek letter, summation, adding stuff up, the letter S. If we want to add up n terms, the sum, we can write it like this, and we plug in these numbers, and that tells us, that allows us to calculate the values of those. They normally use I for the index of summation, the things you're adding up, sometimes J or K. A sub I is the ith term of the sum, so A sub 10 is the 10th term. The subscript is telling you which number in the list you're looking at, and then n is the upper bound of the summation. The lower bound doesn't have to be 1. It can start with different numbers. We could say add up the 4th through the 10th numbers. So it could start at 4, start at 0. All right. So find the sum here. So one way we could find the sum is we could just find the numbers and add them up. Now, if there's just a couple numbers, that's not a big deal. But if there's 1,000 numbers, that could be pretty cumbersome. We would use a computer to do something like that, unless we had a formula, which we have some formulas we'll take a look at. But anyway, so here we're just going to plug in 2. So it's going to be 2 plus 3 times, and then I, that's what we're plugging in. So we're plugging in 2 to find the second term. That's what we're going to do. We're going to add up the second to the 7th terms. So that's 6 plus 2, so that's going to be 8. Okay, now I'm not going to write that out every time, because the thing we do is we'll plug in 3 here. 3 times 3 is 9, plus 2 is 11. And the 4th term is 14, and the 5th term is plug in 5, that's going to be 17. And you can probably see a pattern actually here. Looks like we're just adding 3 each time, so that should be 20 and 23 probably. Now, when I add stuff together like this, maybe I look for some things, shortcuts that I can take. So here, if I add these two together, that's going to be 30, 40, 50, 60. So this adds up to 60, 70, 85. So 85 and 8. I know you can do that in your head, but you don't want to do too much. 13, so 93. So that equals 93. Okay. Now this next one looks a little bit different, but let's see what's going on there. So we're going to look at the first. So if we put a 1 in there, that's going to be negative 1 to the first power times 2 times 1. So that's going to be negative 1 times 2, so that's going to be negative 2. Okay. And a sub 2, that's going to be negative 1 squared, which is going to kind of knock it out. It's going to be positive 1. Plug in 2 here, we'll have 2 times 2. So that's going to be 4. And then 2 more. So negative 1 cubed, we're going to be back to a negative, and 2 times 3, that's going to be negative 6. And finally, stopping at the 4th term, negative 1 to the 4th is going to be positive. 2 times 4 is going to be 8. Okay, so here I would add up the positives and the negatives, except when I started out at the negatives, I'd get negative 8, and I'd realize that that negative 8 will cancel out this positive 8, and it essentially just leaves us with 4. Okay. Just kind of get a little background with sigma notation. Hopefully you worked with this a little bit last year or two. All right, so use sigma notation for this. So we can see stuff's getting filled in here. So it says use sigma notation. So your first kind of thing is probably you should have a sigma there. Mine's a little squished on top, but that's all right. I'm just going to go ahead and use I, because that's what we have on those. Well, that was a K, but and it looks like we're starting with 1. So I'll start with 1. It looks like we're ending with n. So I'll put n right there, and it looks like it's a square root. And then it looks like I plus I cubed. So it's going to be I plus I cubed. And that's it. Okay. So we have some formulas here. So obviously, if we have a lot of numbers, that's going to be cumbersome. We don't want to sit there and calculate all the numbers and then add them up. So the first formula is pretty basic. It's if we have a constant. So if you think about it, like what if we had I equals 1, let's go 1 to 100 of 7. Okay, so if you think about what that means 7 plus 7 plus 7, and there would be 100 of those. So if you have a constant and you're starting at 1 and going to whatever, you're just going to multiply that constant times how many there are going to be. So it's 7 times 100, so that would be 700. So that's pretty basic. Now, we have 3 main formulas here that we're going to be accountable for. And I didn't used to emphasize this very much because I don't remember it being on the AP test the first few years that I taught it. But it seems like there's been a question the last, I don't know about last year, but the year before, a couple years before that. So I'm making a little bit bigger deal about it now. So we probably should go ahead and memorize these 3 formulas. Now that sounds like a lot, but when you compare them and put them all, if you memorize all 3 of these together at one time, I don't think it's as big a deal as memorizing 3 things. So first of all 3 of the formulas have n times n plus 1. So that's the first kind of thing that I'm going to remember. All of these formulas have n times n plus 1. The next thing I remember is that I cubed is the formula for I squared. So that's a little awkward, but if we take the formula for I and square it, we get the formula for I cubed. So that's the second thing I would remember. They all have this in them. The I cubed formula is I squared. To remember the denominators, I put them together, and I just remember 264. That goes in order, 264. That's what we're dividing by in the 3 formulas. In the first formula, we divide by 2. In the second formula, we divide by 6. In the third formula, we divide by 4, 264. And so then the last thing I just have to remember is that the I squared formula, I have to have that 2n plus 1. So that's the only thing that's a little bit awkward. The middle formula has a 2n plus 1. 2n plus 1. Okay, so evaluate this sum using those formulas, and I would suggest that you try to do it without looking at them. So there we go. Although you probably can still see yours unless you put a piece of paper over it. So the first thing I would do is distribute that k and then separate this into 2. So we've got k equals 1 to 30 of k squared plus k. All right. So now I need to apply those 2 formulas. So k squared was the middle formula. All right. So the middle formula was, do I want to just plug the numbers in? It was n times n plus 1. So that's going to be, I don't know how much of that I want to write out. N times n plus 1 times 2n plus 1. That was the middle formula, so that'd be 264, so 6 is in the middle. And the formula for this is just the first formula. That was just n times n plus 1 over 2. So those are the formulas that I'm using. I just tried to make myself remember them and write them down. So now if I want to apply that, n is 30, so that's going to be 30 times 31 times 61 over 6 plus 30 times 31 over 2. Okay, so that's 5. So, is that how I want to do it? I think so. So that's going to reduce to 5. This is going to reduce to 15. Both of those have a 31, and I think I'm going to do it with the 5 too, factor out the 5 as well. So I'm going to factor out a 5 and a 31. So 5 times 31, and that would leave us with 61 here, and 5 and 31, that leaves us with 3 here. Okay, so we have 5 times 31 times 64, so that's 155 times 64, so that's 2620, 0, carry the 3, 33, 9, so 9,920. Okay, so that's some review. Alright, so those of you who had honors geometry here, we did something like this, area under the curve. So we can use rectangles to approximate the area underneath here. So the way we're going to do that is, so this problem gave us a parabola. We stretched out the scale here to spread it out a little bit. And they want us to find the area from 0 to 2 underneath that parabola. So 4 subintervals, that's going to be n, so n equals 4. Now the area is going to equal the base of the rectangle times the height of the rectangle. Now the height of the rectangle, we're going to use h sub I, because there's going to be 4 different heights for these 4 different rectangles. Okay, b, the base of each rectangle, is going to be found by taking b minus a divided by n. So a is the starting number, b is the ending number, so by subtracting those, that gives us the length, and then dividing by how many they told us to use, that will tell us the width of each one. So in this problem, 2 minus 0 divided by 4 is a half, so that tells us that each of our 4 bases is going to be a half. All right? And then the height is a little bit trickier. So the height is going to vary by the function, and that's going to be the starting number and then plus b minus a over n times I. So that is the starting number plus the base moving over each time. Now this is from the right side, so we're starting actually on the right at 2, and we're coming over this way for our 4 rectangles. Now if we start on the left, it starts over here, and you see those rectangles are below the graph, but we'll talk about that in a minute. So I think that's good for that right now. It says, is this one going to be an overestimate or an underestimate? So let's think about that for a second. Probably doesn't take very long to look here. We can see that these rectangles all go above the graph. So what we want to focus on here is, this is, for the part that we're looking at, this is an increasing function. So if you have an increasing function, or you're looking at an increasing portion of a function, then the right sum is over. Because if it's increasing and you're starting on the right side, you're always going to be over the graph. And over here, on an increasing function, or an increasing portion of a function, the left sum will always be under. Okay? Alright, so now the area here. Now, if we just want to do this from using the graph and doing it manually and not using a formula, then we would have 1/2 as our first base, and f of, and using that formula, we would have 0 plus 1/2 times 1 for our first value, and then we would have f of, and for our second one we have 0 plus, and we would have 2 minus 0 over 4, again we'd have 1/2, except this time would be times 2, and then we would have 2 more of those. So what we're showing here is 0 plus 1/2, that's the f value at 1/2, f of 1/2. So let's just break that down. So we would have 1/2 times f of 1/2, and actually, hopefully you can see that these would all be 1/2, so we might as well factor that out. So now, so these are just those y values that we would get from those, plugging those 4 numbers in. Okay, so if we do that, we plug in 1/2 in there. 1/2 squared is 1/4. 1/4 plus 2. 2 is 8/4, so 1/4 plus 8/4 is 9/4. And if we plug 1 in there, we just get 3. And if we plug 3/2 in there, we're going to get 9/4 plus 8/4, so that's going to be 17/4. And if we plug 2 in there, 2 squared is 4, plus 2 is 6. Okay. All right, so just to go over where these values came from, I'm going to do a little t-chart just to try to make it a little more clear. So there is, so we didn't plug in 0, we started with 1/2, but I'm going to start with 0 anyway. So if I plug 0 in there, I would get 2. And then 1/2, 1, 3/2, and 2. Okay, so that was, I already talked about this, that was 9/4, that was 3, this is going to be 17/4, and that's going to be 6. Alright, so we're doing the right endpoints, so that would be these 4 right here. So that's where those 4 numbers came from. Okay. So now, if we combine some of this stuff here, we would have 1/2, and probably we would add these two together, so that would be 26 over 4, which would be 13 over 2. And then this would be 9, but I'm going to go ahead and get a common denominator, so that would be 18 over 2. So that's going to be 31 over 2. Suppose I'll do that. 31 over 2. So that's going to be 31 over 4. Okay? Now, clearly if we were going to do more rectangles, or even that was kind of cumbersome, but if the equation was more complicated, or we would have some problems there. So what if we use this formula instead? We found the summation. The bases were always 1/2. And this was the height, and plugging in these numbers was giving us those different heights, and we're adding those up. So this formula breaks that down for us. So first of all, we can factor out this 1/2 outside the sigma. So that could go out here. And then the sigma is still there, and that's going from That's going from 1 to 4 still. And then what we have here is 1/2 I squared plus 2. That's the formula for f of x, is x squared plus 2. So we're squaring that and then adding 2. Now, That was just because A was 0. If A wasn't 0, we would have that in there also, whatever, plus. So maybe I should have put that in there, 0 plus 1/2 I. But I didn't. Okay, so if we break that down, we've got that 1/2 there. And then if we square this, we get 1/4 I squared. So we could factor the 1/4 out. Oops, not a very good sigma there again. And then we would have I squared. Plus, and then we still have the constant there. So that's I equals 1 to 4 of 2. Okay. So, if we break that stuff down, that's going to be, we got 1/4 here. Now we're using the formula for I squared where n is 4. So remember, I squared is the middle formula. So the middle formula was n times n plus 1 times 2n plus 1. So over 6, the middle formula. And then this formula was that times the constant, so 4 times 2. All right? So these 4's cancel out. 3 goes into here twice. 3 goes into 9 3 times. Okay. So where does that leave us? 1/2. 5 times 3 is 15 over 2 plus 8 over 1. So I want to get a common denominator here. So 8 over 1 is 16 over 2. And that's 31 over 2. So that's 31 over 4. So this shows that the formulas work for the manual work that we did right there. Now you say, why would, that's kind of, is that much less work than that? No, but if we had 40 rectangles, then this would be a lot better than that. So that's where we're headed with that. So it says we could repeat that to find the lower approximation using the left endpoints. So now if we go back to here, we can do 1/2, but if we did the left endpoints, we would be on that side. So we would have 2 and 9/4 and 3 and 17/4. Okay, so that would be 5 plus 26, so 13 over 2 again. So this would be 10 over 2. That would be 26 over 2, which would be, hold on a second, 23. So that would be 23 over 4. Okay. For the one on the right up there, coming from the left side. So clearly these area of these rectangles would be less than the area of those rectangles. Now, the area of the actual region, if we think about it, is going to be somewhere in between those two, because that's under and that's over. Okay? So one thing we could do is find the average of those. So we could add those together and then divide that by 2. So that would be, what is that, 54 over 4. So 54 over 4 is 27 over 2. So that would be 27 over 4. Which we could have figured out pretty quickly here. Actually, the difference between those is 8. So half of 8 is 4. So there we go. So that works. All right, so what this really is right here is kind of the integration version of the limit definition of the derivative. So back in section 2.1, we did the long process where we took f of x plus delta x minus f of x over delta x, the limit as delta x approached 0. And that was the long way to find the derivative. So this would be kind of the long way to find an integral. And I don't think they're going to ask you to do the whole process, but they may ask you to do part of it. So that's why I've highlighted example 5 as something we want to try to make sure maybe we can do that or not. That's not going to, it's going to be one question at the most, probably one. The multiple choice question is worth 1.2 points each. So it's definitely not a big deal if you're struggling with this, but we should try it. So the area under the curve, if you think about it, so when we had 4 rectangles, we had those bigger gaps. If we had more rectangles, that would fill in those gaps more. So how many rectangles do we want? We actually want infinity rectangles. If we have infinity rectangles, it's going to fill in all those things and give us the actual answer there. So this part of the formula is all the same from the other page. We're doing the sum of that, and then we're adding the limit as n approaches infinity. So they're asking us to break this down, and I'm hoping that we can do this part. So the first thing you're going to do is get the n out of the way. So that's going to be 1 over n squared. So that's going to come out. Now, that's going to leave us with the sum of these two things. So we're going to split those up also. And I'm going to factor out that 6. So that's going to be 6. And there's the sigma to n of I. And then here we just have 1. So that's going to be 1 to n of 1. All right. So now we're going to apply the formula to this. So the formula for that is n for I is just n times n plus 1 over 2. Hopefully you're starting to memorize parts of those formulas if you've been kind of thinking about them on your own instead of looking them up each time. And then over here, we're just going to have n times 1 because the constant's 1. So if we add up a bunch of 1s, it's just going to be however many 1s we have. So that's going to be n. Okay. So here, 2 goes into here 3 times. We can reduce that. And we can multiply this out. So that's going to be 1 over n squared. This is going to be 3n times n, so that's going to be 3n squared plus 3n. And then we have that n over there. Okay, so now we have 1 over n squared times, that's going to be 3n squared plus 4n. And if we distribute that, we're going to have 3 plus 4 over n. Okay? Because you would have n squared over n and n over n squared. So now we'll go back and we'll actually do the limit as n approaches infinity of this. So that's going to give us 4 over infinity, which is basically going to go to 0. So 3 plus 0. So that's going to be 3. The answer to that question as n approaches infinity is 3. Okay. So focus on being able to do that. Now, I am going to show you 2 of these where we do the whole thing. So they're not going to ask you to do this the whole way because it takes too long. But you should be aware, and you should have it in your notes in case you end up taking calculus again, just in case they do some stuff with this. So let's start off. We have a and b here. So that's going to be b minus a over n. Now, we're going to leave that as n because we're going to let n approach infinity. Okay. So putting that whole thing together, we have the limit as n approaches infinity of the sum as I equals 1 to n. Now we have the function, and remember, this is where I talked about I could have put in 0 on the other one, 0 plus, and we're going to have 3 over n times I. That's getting plugged into the function. That's giving us the different heights that we have there. And then we're multiplying by the base, which is going to be a constant, 3 over n. Okay. All right. So now I'm going to break down this right here. So this is getting plugged into here. So that's going to be, and I'm not going to keep writing all this stuff down. I'm just going to simplify this stuff here, and then I'll bring that stuff back. So as long as you don't put an equal sign there, you should be fine. We're just doing some work on this. So the formula, the function, is 9 minus, and then we're going to be plugging in this. So that's going to be 3 over n times I squared. Okay? And then we have 3 over n right here. Okay, so if we square that, we would get 9 over n squared I squared times 3 over n. Okay. Now, let's bring back the sigma and factor this out. So that's going to be 3 over n, and then we have the sigma, but let's go ahead and separate the sigma out now. So sigma of 9 as I goes from 1 to n. And then over here, we're going to factor out the 9 over n. Get that out of the way. And that's going to be our I squared. Okay? So now this is 3 over n. And this is 9n. And now the I squared formula, that's n times n plus 1 times 2n plus 1 over 6. Okay? Now, we can do a couple things here. We can cancel this squared off with this n, and we can factor a 3 out of here and here. Okay, so now let's see what happens here. So now we're going to bring the limit back, and we're going to let n approach infinity, and we're going to distribute here. So these n's are going to cancel, and we're just going to have 27. Alright, now, this is kind of a mess, and I don't really want to break it all down, but if we look at this, we would have the first, let's think of the first term. I probably should have just multiplied that all out and listed it out for you. Wonder if I can squeeze that in somewhere. So I'll try and squeeze it in at the bottom just so we have room. So let's multiply this stuff out. So if we FOIL that, so we'd have negative 3, that's negative 3 over n. And inside here, we're going to have 2n squared. And then we're going to have 3n, and then we're going to have plus 1. And that's all over 2. Okay, so if we multiply that out, now if we're going to multiply, so I started multiplying this out, I multiplied that trinomial out right here, and then we also have this 3 over n here that we need to multiply by as well. So there's going to be 3 terms here. So this is negative 9 over n squared. And then I need to divide these all by 2, and then I need to distribute. So I'm not doing this this is not very clean, I apologize. But anyway, so let's just focus on this right here. So these 2's will cancel out, and I'll have negative 9, and these n squareds will cancel out. So that's going to be negative 9. Now let's focus on this term in here. So that's going to be negative 27 over 2, and that n will cancel out one of those n's. So that'll be negative 27 over 2n. And then if we cover all this up, that's just going to be negative 9 over n squared. So when I do this, I don't multiply this all out. So normally I focus on that first term where I know there's going to be that n squared and the n squared, because those n squareds are going to cancel and just leave me with the 9. Now after that, I know that I'm going to have n's in my denominator for all of the terms after that, because those powers are going down, those exponents are going down by 1 each time. So I have n squared, and the n squared cancels the n squared out here. But the next one's just going to be 1n, and that's going to leave me an n here. And the next one has no n's in it. That's just a constant. So that's going to leave me with an n squared. So I'll go ahead and write them down since I calculated it out here. I'm not going to do that next time. But so it's going to be 27 over 2n and 9 over n squared. Okay, and so here's why I don't really worry about this stuff down here, because as n goes to infinity on these two things, they're going to go towards 0. So I don't really need to worry about that. We're just going to be left with 27 minus 9, which is 18. Okay. So on this next one, I'm going to focus on showing you how I normally do that instead of multiplying that all out. I normally don't multiply all that out, so I'll try and show it on this next one. All right. So same thing here. So you've got the limit as n approaches infinity of sigma from 1 to n. I guess I could have calculated that, so that's going to be 4 minus 1 over n. That's going to be 3 over n. Okay. So here we have the function, and now this time we're starting at 1, so this is going to be a 1 instead of a 0. Plus, and then same thing here, so that's going to be 3 over n times I times, now that's just a coincidence that turned out to be 3, because we went from 1 to 4 and this one went from 0 to 3, so they're both 3 over n, but that's going to depend on what you have here. I don't know if you have any of these on an assignment where you have to do it all the way out like this. Let's just keep going. So if we're going to plug that in, that's going to give us 1 plus 3 over n I squared times 3 over n. So we're just plugging this into the formula right there. So if we square that out, that is going to be, let's do this slightly differently. So let's go ahead and factor out the 3 over n with the sigma there. And then let's go ahead and multiply that out. So that's going to be 1, and then this times this will be one of those, and this times this will be another one. If you need to, write it out as 2 over here. So that would be 3n over I plus 3n over I. So they have a common denominator, so we add those up, that's going to be 6 over n I. And then if we square that, we're going to get 9 over n squared I squared. Okay? So the next step would be to separate out those sigmas. So we're going to have sigma 1 to n of 1 plus, and we're going to factor out that 6 over n right there, and 1 to n of I, and I could use parentheses there. Either way, doesn't matter. Okay. So now we have 3 over n. So this is going to be n. this is going to be 6 over n. Now you got to use the formula for I, so that's going to be n times n plus 1 over 2. And then down here, now this looks cumbersome, but we're just filling stuff in that's memorized. So I guess we didn't do any with I cubed. That's interesting. But n squared is n times n plus 1 times 2n plus 1 over 6. Okay. Now, here's where I try to skip some stuff inside here. I just want to focus on a few things. So if we distribute this, these ends cancel and we just have a 3 there. So that's nice. Now, here, focus on the first term. So the first term would be 6n squared over 2n, but also times 3 over n. So this is 6n squared. Here's an n squared down here. So the n squareds are going to cancel. So we're going to have 3 times 6 over 2. So that's going to be 9. Now, if you want to see that whole thing out, it would be 9n squared over n squared. But the n squareds are going to cancel. Now, the next term, I don't really care because I know it's just, there's only going to be one n, 6n times 3 over 2n squared. The point is that there's just going to be an n down here. Okay, so whatever these numbers are, I mean, we can do it. It's pretty much the same. So it's 18 over 2, which is 9. So that would be 9n. So technically it's 9n over n squared. But the whole point is that the n over n squared is going to reduce to 9 over n, and when n goes to infinity, that's going to go to 0. So on this next one, there's more. I'm not going to do all those. So I just want, what's happening with the first term? That's going to be 18n cubed times 3, and then on the denominator, it's going to be 6n cubed. So the n cubes are going to cancel. Okay, so let's write that 6n cubed. And then up here, that's going to be, what did we say? 18 times 3, 54 n cubed. Okay, so those are going to, the n cubes are going to cancel. That's why that matters. And then I'm going to get 2 more terms here, but they're going to go to 0. So normally I would just put dot, dot, dot here as well. So that's going to be 3 plus 9. And then this, am I missing something there? All right, so this is going to be 0. And then this is going to be 9. And then we would get 2 zeros down there on the edge. And I'm not that worried about that. So if you add that up, that's going to be 21. Okay? All right. That's a lot. I'm going to pause there before I do the last thing.